Hello students, welcome to Rayat Shikshan Sanstha's ROSE project of 11th Science conducted by Yashwantrao Chavan Institute of Science, Satara. Myself, Savita Patil from Yashwantrao Chavan Institute of Science, Satara. And today we are going to study topic number 6 from 11th Physics, Mechanical Properties of Solids. In this topic, we are going to study these points. So, let's start today's lecture. In this lecture, we will study these points. We know that rigid body means body which does not change its shape and size on the application of an external force. For such a body, distance between its any two particles remains constant. For example, iron rod is an rigid body. All rigid bodies to some extent are elastic in nature. Their dimensions means their shape and size can be changed by applying external force on them. Let us consider about solids. We know that solids possess definite shape and size. Why solid possess definite shape and size? Because solids are made up of atoms or group of atoms which are placed close to each other. And that's why solids possess definite shape and size. For example, cube. Cube has definite shape and size. When an external force is applied on a solid, then molecules or constituents or atoms of the solid slightly displaces from their equilibrium position, due to which there is a change in shape and size of the solid. Also, due to an external applied force, restoring forces are developed within the solid. Now, what is meant by restoring force? Restoring force means the force which acts to bring a body to its equilibrium position. Restoring force is also defined as, on deformation, the intermolecular forces set up in the body, which tends to restore the original configuration of the body. Such a force is called as restoring force. Here, original configuration of a body means original shape and size of the body. Restoring forces tries to bring the constituents of a body back to their equilibrium position so that solid or body can regain its original shape and size. Let us consider example of spring. When force is applied at both the ends of the spring, then it gets elongates, means its length increases. There is a change in shape and size of the spring. And due to the applied force, restoring forces are developed within the spring. मग स्प्रिंग मध्ये डेव्हलप झालेल्या रिस्टोरिंग फोर्सचा रोल काय? तर ज्या वेळेस स्प्रिंग वरती अप्लाइड केलेले फोर्सेस रिमूव्ह केले जाईल त्यावेळेस स्प्रिंग मधील रिस्टोरिंग फोर्स त्या स्प्रिंगला तिच्या इक्विलिब्रियम पोझिशन मध्ये परत आणतील, म्हणजेच तिच्या ओरिजिनल शेप आणि साईज मध्ये परत आणतील. सो रिस्टोरिंग फोर्स विदिन द स्प्रिंग bring the spring to its original shape and size on the removal of applied force. When the external applied force are removed, the interatomic forces tends to restore the original positions of the molecules, and thus the body regain its original shape and size. However, this is possible only within certain limit. Now, let us see what is meant by deformation. Deformation means the change in shape or size or both of an body due to an external force. Let us consider example. This is a dough. Dough means कणकेचा गोळा. When external forces applied on the dough, then there is a change in its shape and size, means it undergoes deformation. And when the applied force on the dough is removed, dough cannot regain its original shape and size. Let us consider another example of rubber band. So this is a rubber band. When force is applied at both the ends of a rubber band, then it gets stretched. Its length increases. There is a change in its shape and size. That means it undergoes deformation. And as soon as applied forces at the ends of a rubber band are removed, rubber band regain its original shape and size. Now, let us see what is meant by deforming force. Deforming force means the force which is responsible for deformation of a body. The deforming force can also be defined as when a force is applied to a solid, the size or shape or both change due to changes in the relative positions of the molecules. Such a force is called as deforming force. In general, deformation is directly proportional to deforming force. And deformation of a body could be in the form of the change in length of a wire, then change in volume of an object, and also the change in shape of a body. We know that when force is applied at the ends of a rubber band, then it gets deformed. That means there is a change in shape and size of the rubber band. And when the applied force at the ends of a rubber band are removed, then rubber band regain its original shape and size. Similarly, when the external force is applied on the dough, then there is a change in shape and size of the dough, means dough gets deformed. But as soon as applied force is removed, dough cannot regain its original shape and size. This shows that rubber band and dough are different in nature, and their nature is decided by a property. The property in case of a rubber band is called as elasticity, and that in case of a dough is called as plasticity. And In this chapter, we will learn more about these two properties. Now, let us see the next point, which is elastic behavior of solids. And in this point, we will discuss about what is meant by elasticity and plasticity. So let us first see what is meant by elasticity. Elasticity means if a body regains its original shape and size after the removal of the deforming force, then such a body is called as elastic body. And the property possessed by a body is called as elasticity. In case of elastic bodies, restoring forces are strong enough to bring the displaced molecules to their original positions. इलास्टिक बॉडीमध्ये जेव्हा आपण एक्सटर्नल अप्लाइड फोर्स अप्लाय करतो इलास्टिक बॉडीवरती, त्यावेळेस रिस्टोरिंग फोर्सेस डेव्हलप होतात अँड दे आर स्ट्रॉंग इनफ, ते स्ट्रॉंग आहेत. त्यामुळे when external applied force on the elastic body are removed, the restoring forces in the elastic bodies restore the body to its original positions. Means body regain its original shape and size as restoring forces are strong in that body. Examples of elastic bodies are metals, rubber band, etc. Elastic body undergoes temporary deformation, and for the deformation of elastic body, large deforming forces required. Now, let us see what is meant by perfectly elastic body. Perfectly elastic body means if a body regains its original shape and size completely and instantaneously upon removal of the deforming force, then such a body is called as perfectly elastic body. Example of perfectly elastic body is quartz fiber. So this is all about elasticity. Now, let us see what is meant by plasticity. If a body does not regain its original shape and size and retains its altered shape or size upon removal of the deforming force, then such a body is called as plastic body, and property possessed by body is called as plasticity. In case of a plastic bodies, restoring forces are not strong enough to bring the molecules back to their original positions. म्हणजेच प्लास्टिक बॉडी मध्ये डेव्हलप होणारे रिस्टोरिंग फोर्सेस जे आहेत, they are almost negligible. As they are negligible, such plastic bodies cannot regain their original shape and size on the removal of external force. Example of plastic body is clay, plasticine, etc. Example of perfectly plastic body is पुट्टी. पुट्टी म्हणजे खिडक्यांच्या काचा बसवताना जी लांबी वापरतात तिला पुट्टी म्हणतात. पुट्टी म्हणजे लांबी. Plastic bodies undergoes permanent deformation. Means once they get deformed, they cannot regain their original shape and size. Then, small deforming force is required for the deformation of plastic bodies. In reality, there is no solid which is perfectly elastic or plastic. All bodies lies within these two limits, that is perfectly elastic and perfectly plastic. So this is all about plasticity. Now, let us see the next point, concept of stress and strain. Elastic properties of bodies are described or explained in terms of a stress and strain. When force is applied on the body, then it gets deformed and restoring forces are developed within the body. These restoring forces developed within the body opposes the change in shape and size of the body. When the body is in its equilibrium state and its altered shape and size, then applied force and restoring force are equal in magnitude but opposite in direction. That means when body is in equilibrium state and its altered shape and size, restoring force and applied force are equal and opposite to each other. Their magnitudes are same, but directions are opposite. Now, let us see what is meant by stress. Stress is defined as the internal restoring force per unit area of a body. So here we can write stress is equal to deforming force per unit area. So let us consider here F bar be the internal restoring force or external applied deforming force, and let A be the area of the body. Then as per definition of stress, we can write equation for stress as stress is equal to magnitude of F bar upon A. Let us write SI unit for stress, and it is Newton per meter square or Pascal. And let's find dimensions for stress. We know that equation for stress is F upon A. So in this equation of stress, let us substitute dimensions of force as L raised to 1, M raised to 1, and T raised to minus 2. And that of area as L raised to 2. So on solving these dimensions, we get dimensions of stress as L raised to minus 1, M raised to 1, T raised to minus 2. So these are the dimensions of stress. So this is all about stress. Now, let us see what is meant by strain. The strain is defined as the ratio of change in dimensions of the body to its original dimensions. So we can write here equation for strain as strain is equal to change in dimensions per unit original dimensions. Here we see that strain is a ratio of two similar quantities. That is, change in dimensions of a body to its original dimensions. Therefore, strain has no unit and dimensions. So, this is all about strain.